Hello, everyone. Thank you for coming to the GPL webinar, which we are featuring EMC, and we're going to cover hyperconverged infrastructure with our VxRAIL solution. Just a little about GPL technology. We are a customized IT service for creatives. We design, implement, and support innovative solutions that are tailored to your business goals and needs. And the services that we provide are managed services, hardware as a service, which is our rentals, and we call VFX Now, technical staffing, which we call BREED, and infrastructure solutions. And that is exactly what we're going to delve into today. We're going to have a Q&A at the end of this, and you'll see there's a Q&A box where you can type your questions in throughout the presentation, so feel free to do that, and we will answer all those questions at the end of the presentation. We'll also be inviting everyone that attends this webinar to our up-and-coming vendor fair that will feature EMC on June 22nd, and so stay tuned for more information on that. But right now, I'd love to introduce Omid Balori.
Thank you, Melissa. Hopefully you can hear me loud and clear.
Absolutely.
Perfect. So I'm Omid Balori. I'm a systems engineer with EMC. I've been here for about 3 years or so. I service the greater LA area. Myself and my colleagues essentially cover the geography. My information is there in the corner. Please feel free to reach out after the meeting if there's any other questions that we might not have answered. Today we'll be taking a look at EMC's delivery of converged infrastructure appliances. We've labeled this VxRAIL. It's modeled after the VMware EvoRail-based platform. We've coupled that engineering option with software and such. We'll dig through it a little bit. As Melissa mentioned, please fill out the questions in the Q&A session, and towards the end of the presentation, we'll dig into those. Just a quick recap as far as what we'll cover. We'll take a look at the VxRAIL overview. We have recently revved the hardware and software, and we'll take a look at what's new in this current build. We'll take a look at the different models and the scalability options between those models, how we grow them, how we stack the Lego building blocks to scale over time. We'll take a look at a little bit under the covers on the architectural details, also the rich data services that we offer in this platform. We'll take a look at the built-in data protection options for backup and replication, and we'll also quickly run through the VxRAIL management. I have a couple of screenshots of the environment and actually what it takes to click through it, showing kind of the ease of use. And last but not least, we'll do a Q&A session towards the end. So what is hyperconverged? I think we've been seeing more and more of this platform throughout our customer base. Our offering is a joint solution from both EMC and VMware. We've come together to design the product. We've come together to deploy it, and we're supporting it end to end. So in this platform, our partner is VCE, who is EMC's converged platforms division. We'll be delivering the solution. We support it end to end, meaning hardware, software, all the way to the VMware stack. It's supported under one call, one service offering, and then operationally, from that point on, as far as upkeep, maintenance, things like that, it's all delivered as a single solution. So it gets customers out of the infrastructure, the world of managing infrastructure, the world of managing individual components and making them work together. This is an end-to-end solution covered by one manufacturer, supported by one manufacturer. As far as use cases and such, we see both virtual desktop workloads, server workloads, hybrid cloud, as well as other things that do fit well in this. It's a scalar architecture, so as the requirements increase over time in your business, we can simply add on more appliances in single node increments and scale the entire environment end to end. So to deploy the solution, we can go from plugging in the power into delivering an end-to-end solution within 15 minutes. I'll show you later in the slide deck the exact process and how simple it really is. That's not a marketing number, it's a true engineering number. This can ship without really any services required from engineers on the manufacturing side. Customer installable, customer configurable, and again, up and running in 15 minutes or so. We do that by automating a lot of the tasks in order to create this environment. There's over 200 different workflows built into this platform where you plug in some information and we do all the work in the background to deliver the infrastructure. When it comes to scaling this environment as you grow, as your business needs increase, It honestly is a 5-minute install to grow this. We start with 4 nodes, and we can scale to 64 nodes in 1 node increments. I mentioned that we've recently revved this environment. We're now up to the VxRAIL 3.5 platform. We've introduced high-density flash. We can get up to 76 terabytes of flash in a 2U container. We've introduced deduplication, data compression, and erasure coding on our flash platforms to get a better bang for the buck. We've also introduced quality of service limitations, so we can essentially have different levels of service, different SLAs for different application stacks. And on top of that, we've also introduced the ability to do metro stretch clusters, which would basically create an active-active environment across 2 different geographies. A couple other the new feature sets. We've introduced all flash models. We're really leading with that message. We're finding more and more customers asking us to deliver our systems in an all-flash manner. We do still offer hybrid, which is a combination of flash and spinning disk where appropriate, maybe for remote offices or small I/O workloads. But with the data compression and deduplication and some of the benefits we have on our all-flash models, the point of inflection for price becomes more and more attractive for flash as we advance. The cost of flash is down. The fact that we can dedupe, compress, and do erasure coding makes it almost as efficient, if not possibly more efficient, than the price of spinning disk. Take a look at the different model sets that we support and the scalability options. It's in its rawest form. This single appliance is actually 4 nodes behind the covers. These 4 nodes fit into a 2U based chassis. From that point, that's the minimum configuration is 4 nodes. From that point on, we can add a single node at a time, and scale all the way to 64 nodes. I mentioned we offer both all-flash nodes and hybrid nodes. Again, we're leading with all-flash because of the fact that it really gets you out of the hardware management business. It takes storage performance off the table. You know that every single I/O is going to be at flash speeds, and there is no more chasing, trying to find bottlenecks in the environment and such. So, as I mentioned, more and more customers are asking us for all-flash solutions because it usually makes more sense. Coupling that with data reduction technologies we have, we can get more out of flash and make it more cost-effective. So here we really have options of density, number of cores needed per node, amount of system memory, the capacity of the storage, as well as network options. We support both RJ45 and SFP+. In the all-flash environment, we suggest 10 gig networking where possible, just to make sure that we're matching the requirements there. So I mentioned the scalability numbers. Again, we can start with a single appliance, which is 4 nodes, and scale up to 16 appliances, which translates to 64 nodes. Translate that to the number of VMs. This is kind of an average VM, so 2 vCPUs, 4 gigs of memory, 40 gig base hard drive. That equals about 200 VMs in a single appliance and up to 3,200 VMs in a fully scaled out model. This is one pool of resources, one pool of deduplication and compression. There is no island approach. So when we start from 1 and go to the 16 appliance model, it's treated as one logical group, one logical cluster. A little bit of a deeper dive into the different models that we offer. As I mentioned, there's both hybrid models, which include spinning disk and flash for some of the caching, and also the all-flash models. I won't dig into the specs too much here. We'll definitely follow up with all the speeds and feeds after the fact if required. The net of it is that we are more dense and more powerful than any other hyperconverged appliance on the market. Within 2 U's of rack space, we can goes dense as 112 CPU cores, 36 terabytes of raw flash. With that raw flash, we can dedupe and compress and use ratio coding to get a substantial amount of logical capacity. Again, all in 2U's. So let's take a little bit of a deeper look into under the covers on how the system works, the technologies we're using, both with VMware and EMC software technologies to produce this platform. First and foremost, we do not use a VSA, a virtual storage appliance approach. Some of the hyper-converged appliances in the market do make use of that approach. We feel that it adds complication, it adds a lot of system requirements just to make storage work. So we're leveraging VMware's vSAN technology, which is an in-kernel type of approach towards storage management. So we don't have the addition of having a VM on top of our VMware environment to support storage requirements. We're doing it in kernel. We're really scratching the surface of CPU utilization. And this slide here says under 10%. In real life, it's about 4% utilization is the overhead for our vSAN technology. If we add a VSA in there, it'd be substantially more. We really have a direct path to I/O, so it's kernel to disk. There's no other layer on top of that. This again is a VMware technology. It's proven in the marketplace. We're adapting that architecture, coupling it with our hardware, and delivering it as a single unified product. How that looks like on the VMware stack is we're basically presenting one large virtual SAN data store. This is actually an object store translated to a file system. So in the background, we're keeping objects. We're not maintaining a file systems underneath the vSAN layer. We're truly keeping objects on disk and presenting them into a single virtual SAN data store. I mentioned before we start at 4 nodes and go up to 64 nodes. If you had a 64-node environment, you'd still be utilizing one large vSAN data store. So it makes it a lot simpler. It makes it a lot easier to maintain. There is no divvying up different storage resources to support certain workloads. It's all sharing one pool. Ease of use is key here. Take a quick look at the data services I mentioned. These data services that we're highlighting here, which is deduplication, compression, and ratio coding, is really available in our all-flash platform only. This would work in a spinning disk environment. However, the latencies of spinning disk would cause it to be unpredictable. So we're really offering this only on our all-flash platforms. That's because flash is obviously a lot more capable of doing certain things than others. So by making use of these technologies and coupling it with the benefits of flash, we're able to have more usable capacity in the environment, have substantially better performance in spinning disk, honestly lower the cost per gig. Because we can dedupe, compress, and use ratio coding on a more expensive platform of flash, we're able to logically translate that to a lower cost of ownership. So basically do more with less. So as far as the ratio coding, we take the approach of single parity or dual parity. For those of you in the storage world, think of it as RAID 5-like and RAID 6-like. We don't actually do the resiliency at the disk level. We actually do it at the object level. So we can take a single object and protect it in a N+1 or N+2 model, just like RAID 5 and RAID 6. Comparing that to a mirror model, which is more like RAID 1 that we do in the hybrid world, this is kind of what I mentioned is more cost effective. So with flash technologies, because of the performance that they offer, we can basically get more out of less and introduce technologies like ratio coding to support that. We see about a 30% savings on the RAID 5 level, on N+1 level, as compared to our spinning disk colleagues, and we see about 50% benefit on the RAID 6-like model. It's just more effective over time. We also do deduplication and compression. It's all in line, so data never lands on disk and is compressed and deduped later, all on the inbound. So we first dedupe, then compress, then lay it down to our object store. So in environments like VDI or even general virtual machining, we see a substantial amount of the same data over and over again. So in a VDI environment, we can easily get 20 to 1 deduplication benefits in a typical environment. So for every 1 terabyte of capacity used, you're allocating 20 terabytes of logical capacity. With general virtual machines that are not VDI, the combination of deduplication and compression, 4 to 1, 5 to 1, things like that make more sense. We also offer the ability to take advantage of hybrid cloud approaches. EMC made an acquisition a couple years ago with Twin Strata. We've taken that technology and basically deployed it to all of our core technologies. We have the ability to present file shares, whether it's NFS, CIFS, or even iSCSI, targeted to the virtual machines, but actually live in the public cloud. So if you had resources in either Amazon, Azure, AT&T, Google, pick your cloud vendor, we're able to take that resource, translate it to a file share, and present it to your virtual machine environment. So in areas where not only do you need physical block I/O, you also need NAS capacities, we have the ability to couple that. This is a built-in technology into the VxRAIL platform and available on day one. This is a bit of an eye chart here. Hopefully you can read it, but it really goes over all the data services in VxRAIL. Again, I'm not even dig through all of them. I just want to do a highlight here. We can definitely follow up with a deep dive into all the data services that are in this environment. So I'll focus in on data protection real quick, and then we'll get into the actual utilization model on how we set this up and into the Q&A session. So we really have 2 different supported technologies, groups of technologies to support data protection. One is for local data protection. We leverage fault domain approach, so we can protect against an appliance, rack, or room level failures. So for example, we can have 2 different sets of the same data across 2 different racks, and we can logically contain these to different fault domains so that if we lose an entire rack, the VM can essentially turn on elsewhere. We also support snaps and clones in the environment, so if there's any kind of a logical corruption at the VM level, we can have constant snapshots in the background that we can revert back to. That'll protect you against really going to tape or going to your backup media. It's more of an online approach. Also built in, we're leveraging VMware's VDP products, so we can do local backups of virtual machines to the same appliance. We also provide you with RP for VM. EMC's had a technology called Recover Point for years now that works on at the storage layer. We've translated that to a virtual machine version. RP for VM stands for Recover Point for Virtual Machines. This is a local backup protection copy. We can basically get down to the granularity of seconds and revert back at a VM level. We take the same approach for disaster recovery. So not only do we protect locally, but also for disaster recovery scenarios. We can replicate using the built-in VDP technology to another site. We also have the ability to leverage VMware's VSR technology to do the same. It's more of an asynchronous copy. I mentioned before we have the option of leveraging EMC's RP for VM. In the same manner, what we can replicate locally, we replicate across the WAN. It's an asynchronous model that has a few seconds versus for an RPO RTO standpoint. We can recover an entire environment within seconds to a sister DR site. We've also introduced the idea of active data centers. Within 5 milliseconds of latency, we can have a stretched VMware cluster on this appliance stack, fully certified by VMware, truly an active model. So we can lose an entire site and be on the other site within a few seconds using VMware's HA technology. Last but not least, licensing. At first, when we released this product, it was a combination of both hardware, software, and support. Hardware is a VxRAIL platform, software would be VMware's vSphere, and support would be done through EMC end-to-end support, meaning VMware down to the hardware, single call. That was a challenge for customers that had ELA licensing from VMware or existing licenses from VMware. So we've changed the model a little bit, and we offer customers the ability to bring their own licensing into the environment. So VxRAIL by itself comes with license for vSAN, licenses for VxRAIL Manager, which is our GUI to basically deploy the environment. We provide you vCenter server licensing, Log Insight as an option, and all the EMC technologies for both replication and bursting to cloud. You also have the ability to tack on VMware licensing either from EMC or bring your own. It's an open option there. So we're utilizing VMware's loyalty program, the VLP, to basically bring your existing licenses from an ELA into this platform and fully supported end to end. Again, it's a single call. So when there's an issue in the environment, you call EMC for end-to-end support. You don't have to call VMware for VMware support and EMC for hardware support. Single call, single throat to choke across the board. So there's really two different models of software licensing that we support on the platform, vSphere Enterprise Plus and vSphere Standard. We recommend Enterprise Plus mostly because of the benefits of data mobility. We want the ability for a VM to move around anywhere on its own for DRS functionality, also for high availability. If there's a problem with the node, things like that, we want things to fail over automatically, so we prefer Enterprise Plus, but we fully support vSphere Standard as well. If that's more cost-effective for you, it's definitely a supported platform. Last but not least, before we dig into Q&A, I want to dig through a couple of slides here that show the actual ease of use on the platform. So I mentioned we use a platform called VxRAIL Manager. When you plug in the environment, you provide a power, you log into a website, and this is kind of what it looks like. You basically provide it simple IP address information. It's a wizard-driven approach. IP addresses for the ESX hosts, IP addresses for vMotion networks, management networks, things of that nature, and the wizard itself will walk through the software solution process. We have integrated software solutions for logging and remote connectivity and such. So we'd also include that information in this wizard. And with a few clicks to the environment, it basically does end-to-end configuration. Those 200 workflows we talked about earlier are a manner of basically preparing and delivering the environment for you. Literally in about 10 to 15 minutes, you get this screen saying you're ready to go. You're fully operational. So at this point, from this point on, you're managing everything under vSphere. We don't have a separate GUI for storage. We don't have a separate GUI for replication. Everything is done through vSphere's web client for both local replication, vSphere, everything. Everything's in a single pane of glass. That's really it at this point. We'll dig into questions. If you haven't done so yet, please log questions in the Q&A section below, and Karen and I will do our best to dig through those.
Thanks so much, Amit. It's great to get to know more about VxRAIL, and if the people that attended today, if you enjoyed this introduction to VxRAIL, then we would love to invite you to join us for in-person presentations and Q&A at our vendor fair that will take place June 22nd, and will feature EMC. And I will be personally sending invites out to all of you. We'll also have this presentation available on our website if you want to look back at it, and please share with friends. And thank you so much, Amit, for telling us more about EMC and VxRAIL. How are we looking on questions?
Hi, Melissa, it's Karen. I do not see any questions at this time.
No questions at this time? Okay. Oh, wait, here we go. What have we got? We have a question from Alan Ignatian. Is the file system that sits atop the object store POSIX compliant, support for extended attributes? Do you have an answer?
So let me put a little bit of clarity there. So under the object store, we deliver VMFS file system, which is a virtual machine file system for VMware. That's where we can put on the VMware objects. The VMware virtual machines. We have an addition additional piece with leveraging CloudArray that delivers basically NAS services under the public object store. Just want to make sure that we're talking about two different things here. The object store for CloudArray, which is the NAS piece, is POSIX compliant. It can be mounted as NFS, CIFS, also HDFS for any Hadoop environments, and it does support extended attributes.
If we have any further questions, please type them into the Q&A box on the webcast interface.
Alan, if you want to reach out after the fact to the GPL team, we can give you a lot more information on that platform. Thanks for the question.
Yep, and so you can always contact us at sales@gpltech.com, and we'll refer you to one of our wonderful sales reps that will get you in contact with also the EMC team that we love working with. If there's no further questions, then I think I'd just like to say thank you so much to Amit and Karen from EMC for putting this together, and looking forward to seeing everyone at the vendor fair and talking more about EMC. It looks like we actually have a few more questions.
Got one more question.
Yeah.
Another question from Alan. Replication from site to site was at 5 milliseconds as mentioned, what about 80 milliseconds? Is there WAN acceleration? So the 5 milliseconds of latency that I mentioned, that's for active environments using VMware's stretch cluster approach. That's a pretty hard requirement because VMware's vMotion requires 10 milliseconds of latency maximum for it to function appropriately. So for an active environment, 5 milliseconds one way is a hard limit. If you exceed that, vMotion will fail. Therefore, HA isn't supported. For replication, for a DR scenario, we support up to 500 milliseconds of latency. Basically, it's a journaling approach. So we would journal the writes locally, send them across the WAN. It is WAN accelerated. We compress and dedupe the actual data going across from site to site, and then uncompress and rehydrate on the target end. If you use WAN acceleration hardware on top of that, even better. However, it does have some built-in replication. So again, 5 milliseconds is for active environments, and we go into the hundreds of milliseconds of latency supported for a DR target. It's asynchronous.
Great, thank you for that answer. Do we have any further questions? Well, again, I hope that everyone can meet us on June 22nd and then be able to talk to the EMC team in person. So thank you again, guys. It was really great.
Thank you. I guess that's a wrap. We appreciate everyone joining.
Absolutely. And we'll talk to everyone in more webinars and hopefully in person soon. Thank you so much. Have a great day.